Now, the first thing we often do is just a visual inspection, looking for bad solder connections and the like. On some of the Sony models, it's very important to do this because if you turn it on the next time, it might blow up from bad solder connections, so there have to be a close inspection there with a magnifying glass. Now, on these models also we see bad solder connections on these modules quite a bit. And of course the occasional blown amplifier channel, which would involve a couple of output transistors and resistors, etc. And let's get to work. Okay, there are some noticeably bad solder connections on those modules, but I am going to plug up the amplifier with some loads on it and see what the output signal looks like. One channel's pretty much out. It tries to blast through there just a little bit when you goose the volume. Okay, on the one channel, there is no bias whatsoever on the output transistors. They're simply not turned on at all. I'm going to turn it off now and check a couple things. Actually, it'd be a good idea to bleed off a little DC voltage before I do too much with it. It's bleeding off relatively quickly on its own, but I can do it quicker. This is an 8 ohm load resistor I'm using to bleed that off quickly. Once it gets under about 20 volts, I don't worry about doing that. The solder connections don't really look bad enough to have caused that problem. Yeah, those solder connections are pretty funky. It's not uncommon for bad solder connections on driver transistors to cause an amplifier channel to blow up. It doesn't appear that that's happened in this case. Bias transistors are critical. It's more likely that if the bias transistor connections opened up that it would blow up the amplifier, but nevertheless I'm going to touch those up very carefully. One thing I failed to check for before was to see if I had normal base emitter junctions on the output transistors. Some flat pack transistors do tend to open up emitter base, but that usually results in an increased voltage at the base and not less, which is what we had going on here. Nevertheless, let's check our junctions. Yeah, they look fine. So far I'm operating under the assumption that nothing's really blown on this amplifier, but that could prove to be overly optimistic. We old people need our magnifying glasses. You'll understand when you get there. No doubt I'll be editing this. If for no other reason, who'd want to watch it? Well, let's give it a try. Since my red flag syndrome was, or symptom, was that there was no forward bias on the output transistors, that's the first thing I'll check. If I have my plus 5.5 or 0.55 or 0.6 volts on the basis of the output transistors. Lo and behold, we appear to have forward bias on the output transistors. How about that? And guess what? We have both channels now. Ha 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 ha. How about that? The remainder of the repair will be concerned with cleaning the controls and checking the speaker relay to making sure that its output is stable. You may need to clean the contacts on the relay, and that'll just about do it. We'll probably have one little wrap-up video to add to this, but that's it for now. Now, if you want to be a real professional technician, it's a nice touch to clean the circuit board where you've been soldering. I'll generally use either acetone or MEK and a stiff brush. This also allows you to inspect the work better afterwards. You might miss a bad solder connection or something if you haven't cleaned the board. Also, it gives a nice professional appearance if somebody else should happen to be judging your work, which happens. Okay. This has been a repair brief by Mark in Wichita, Kansas. I hope you found it useful. See you next time.